So the fires are over there somewhere. You can see the smoke. You can hear the fan on this thing. The drone overheated. We had to stop and land it. It's about 109 out. So we're going to use the air conditioning to cool the drone off. Hopefully get it back in the air. Here we are in a 2018 JK with an LS3. We just pulled this Jeep out of the shop. I'm going to go for a test drive. It is pretty hot out. Don't let that fool you. It's about 113. This Jeep was in the shade. You notice we have a check engine light on. We have a PO315 in this Jeep, which is crankshaft variation not learned. Now don't get fooled to think you got a bad crankshaft position sensor. You don't. Crankshaft variation not learned means that there is it's basically an emissions nuisance code, and it wants you to do a procedure to learn the crankshaft pattern, and it uses that crankshaft pattern for misfire detection and other things. So essentially what we're going to do is we're going to take a picture of the crankshaft pattern so the computer can use it for comparative purposes on actual running. So it compares this crankshaft pattern to the crankshaft pattern when the vehicle's running, and if there's enough of a variation, then it can detect a misfire and throw a misfire code. A couple of things: when you do the crankshaft variation learn, you want to have your left foot on the brake and you're going to use your right foot to floor it. You're going to have to turn the air conditioning off. Doesn't matter if you have the fan on, you just don't want the compressor on. And in park. Now I'm going to use EFI Live here because EFI Live is about the most difficult software to do this with. There's no prompts. So you're going to open up, let me close it and then open it again so you can see what we're using here. We're going to be using the EFI Live scan tool. You can do it with HP tuners, you can do it with an OnTel, you can do it with a Snap-on. Those other tools give you a lot more prompts. It tells you, put your foot on the brake, turn the air conditioning off, blah, blah, blah. EFI Live doesn't tell you anything, and that's kind of why I want to do it with EFI Live. If we are successful, we're going to see this light go out, which basically means it took the picture. Now, the GM manual says turn the key off for 30 seconds. I find that you don't have to do that sometimes. The light will just go out. And if you look at the history, after you do the learn, the 315 may stay in history, so you can clear it after that, and the light should stay off, and the code should stay out of history. If you just do the learn procedure, the light will go off, but the code may still report in history. So first thing we're going to do is we're going to connect to the vehicle. When you come down here, we can record or look at the live data. Let's look at the live data. We're going to go to the ECM setup, and we have a learn crankshaft angle sensor, or case learn. So the engine has to be over, I think it's about 160, 170 degrees in order to do this. So we're going to activate, and notice there's no prompts here. It's just not really telling us anything. But let's just go ahead and we're going to put our left foot on the brake. I'm not sure if you can see that. And then we're just going to floor it with our right foot and see if this check engine light goes out. Here we go. Now, before I do that, let me just say, this throttle is going to hit about 4,000 RPM, and then the RPMs are going to cut off. The fuel is going to cut off. If it doesn't cut off and it continues to rev and hit the rev limiter, then let off, because the procedure is not successful. A proper procedure, once you have it in this learn mode, will cut the throttle off between about 3,500 and 4,000 RPM. So I'm just going to floor it, and don't go light on it. You just really got to press the pedal all the way to the floor, and let's see what happens. Now that did not learn. You saw it go to the red line, and it doesn't happen every time. Now, I didn't see OK before, now I see OK now. And this is why EFI Live can be difficult to work with, because it doesn't really tell you. So I'm guessing that this OK means now that we're in this learn procedure. Let's try it again. Okay, you saw it cut off that time, just over 3,000 RPM, and our check engine light went out. Now we can see the check engine light is out. We got our fan in the background. I'm sorry about the noise, but with the air conditioning on it, it's winding up pretty good. And like I say, it is about 113 out today, so the AC pressure is probably about 300 PSI. We're going to check the codes with a little bit different software, something that's a little more convenient. This is my Torque app. You're going to go to real-time information. Now, this page shows actual GPS speed versus the indicated speed in the GM computer, and there's actually even an offset parameter, and that helps me calibrate the speedometers. This is my temperature page, and as you can see, the AC pressure is about 300 psi. The trans temp isn't working on this Bluetooth. It'll pop in and out. I'm not really sure why, but on some of these adapters, the trans temp on the LS doesn't work all the time, but everything else here is working. So let's, our fuel trims are pretty good. That's a parameter I look at quite often. Let's go back to codes. Now my guess is we're probably going to end up having well, there we go. We got a PO315. Let's refresh it to see if it's still in history. What matters is it's not current, and it's not. It's historic, and you can see our lights out. So let's just go ahead and clear it. All right, so we pulled the Jeep out of the shop, and the temps have normalized. It's saying 120. I think we're more about 117. At least that's what the news is saying. And we got our air conditioning on and all that. So this is basically my temperature page, I call it. You can see our coolant temp up there in the top left, oil temp, intake temp. Now the intake temps on this vehicle are a little bit high right now because we've been idling here in traffic. This vehicle does not have our intake air shield on it yet, but it will soon, and then you're going to see those temps come down a little bit. The trans temp, as I indicated, is not showing right now. It'll pop in and out. Let's turn this AC to high, and you're going to see that AC pressure shoot up to about 300 psi. Now you got to remember, we got a pretty powerful Camaro SS fan in here, so it can drive that AC condenser pressure down, but the reality is at 120 degrees the AC pressure is just going to be high. It is what it is. Our control module voltage is good. We're pushing almost 14 volts, and what you really want to look at right now is that spark knock. I've already pulled 3 degrees out of this LS3, and it's doing pretty good. I was getting some pretty significant spark knock when I first took off, and I pulled out about 3 degrees. The fuel is very important also. Remember, the LS3 is a higher compression engine, so you want to make sure you run a good grade of fuel. Alright, so we're cruising down the road here. Coolant temp staying good, about 205. And guys, you don't want to see these engines run at 175 degrees. What we want to look at right now is that spark knock, and you can see it's popping in here and there. It's really hot out. It's probably close to 120, and we have a relatively high intake air temp. So see that spark knock kicking in there? I'm not sure what fuel is in this. I'm not sure what fuel the customer had in it when he dropped it off, but we're going to throw some premium in it, and I'm seeing this constant spark knock, so we're going to have to stop and back that off. We haven't gone very far, and we're already down to 2 monitors. We do use full monitor support. So we have the rear O2 sensors, we have a evap system. Now you're not going to see the evap system and the O2 set right away. Those codes take a while, especially the evap. It could take a couple of days, heat, hot, and cold cycles for that evap to set. There are procedures to force the evap to set faster, but it's pretty good that we're down to just those 2 and not driving a very far distance. As I told you guys before, reading these O2s is like reading a scope or a book. They can tell you a lot about the engine, how it's running. This is our injector pulse over here, but these O2s tell the whole story once you learn how to read them. Back to the temperature page, I'm not liking that spark knock, and I'm not even under a moderate load. I'm under a light load, and I'm seeing that spark knock. So the high compression of this LS3 is coming through, and we're looking at it, and I can actually feel the power back off when it hits that spark knock, and then the computer pulls it out. So we don't want to be there. Coolant temp still staying good. AC pressure about 300 psi. We're good there. The oil temp is a calculated value. It's not a real value. It doesn't have an actual oil temp sensor in there. But if you're going to be running around in the Southwest where it really is hot, go ahead and put an oil cooler on. We have a rock rail cooler that we put in for engine oil. And one of the nice things about a rail cooler is both engine and oil is it offboards the hot air. Instead of putting it into the radiator and into the AC condenser and into the engine compartment, it's putting it out into the atmosphere where it's not going to be putting more heat under your hood. So I would say if you're going to be operating in really high temps in the Southwest, or you got 40s on your Jeep, go ahead and add an additional engine oil cooler. So this would be a good time to talk about fans. I've been getting a lot of questions about fans lately, guys that have Hemis, guys that have V6s. And I've gone over this in my previous videos, but we're going to talk about it again because with the heat wave going across the country, and here in the Southwest, temperatures are, I don't think they're record. I mean, I've seen hotter summers in it. So the early JK fan was a single wound 2-speed brushed fan. Basically, it was a DC brushed motor, and with a DC brushed motor, a simple motor, you put more voltage in and it spins faster. There's a kV value. So by increasing the voltage, the fan would spin faster. By decreasing the voltage, the fan would spin slower. Now, a true dual wound, dual speed fan is really the way to go, and Jeep did that in the higher end vehicles like the Grand Cherokees. It costs more, it's bigger, but it is a better setup. You can literally burn out one set of windings and still run off the other one. Well, what Jeep did on the JK is they kind of cheaped out. They went with a single wound fan, and they used a voltage divider, or as some of you guys call it, the fan resistor on the 3.8. And what that does is it basically just bleeds some voltage back, because remember, voltage is electrical pressure, current is electrical volume. So it bleeds some of that pressure off, which slows the fan down, and it runs at about 8 volts on low speed. The low speed relay is in the TIPM, and it is powered by the TIPM. The high speed relay is behind the driver headlight, or on top of the driver headlight, and it essentially feeds full power to the fan, and that power does not go through the TIPM because it's a lot of current, and if you were to run that through the TIPM, you probably could damage it. Most of us know the TIPM is already a grenade with a pin out, and I've actually replaced a lot of TIPMs because the fan control for the high-speed relay burns out, and then it no longer has the ability to turn the high-speed fan on. Now, watch that relay carefully, because especially in challenging conditions, that relay gets really hot, and that's why they put it behind the driver headlight, is to get some cooling air. But I've seen them melt, and they melt often. One of the reasons they melt, and this is just kind of a lesson in the JK cooling system, is the fan having a single wound motor means that when you apply 12 volts to it, it just goes from off to high. There is nothing to stage it. And it's a relatively powerful motor. It's nothing like an SS fan or a Pentastar, but it's powerful enough to where when you go from off to high, there is a high voltage spike or an inductive kick. And that kick can be 20, 30 amps, 30, 40 volts. And you do that over and over and over, and that's very stressful on an electronic component like a relay. So the typical scenario is your low speed circuit burns out, the resistor goes bad, engine never has a low speed, or the fan never runs at low speed. It goes from off to high. When you go from off to low to high, it kind of stages the amperage up, and it protects that high speed relay. But when you go from off to high and off to high over and over, it eventually burns that relay out. It gets really hot, and you can pull the relay out from above that driver headlight, and you might see that it's melted. The connector melts, or the relay itself melts. I've had to cut off the connectors in some cases. So the way Jeep got those 2 speeds is by using that voltage divider, by putting that resistance in the low speed circuit. It returns some of the voltage back, and it drops the voltage going to the fan to about 8 volts, and therefore your fan runs at low speed. It's an economical way of getting a 2-speed fan. The early JK fan motor, being an in-runner, so the inside part of the motor is the rotor, it turns, means it doesn't have a whole lot of torque. So the fan blade is 17 inches. The JK core is about 22, 23 inches, as I remember. So technically you could use a bigger blade, but really that's what the motor supports, and it does a pretty good job for the 3.8. You put a V8 in it, you supercharge it, or even if you're running your 3.8 out here in the desert, it's just not enough. So the 3.8 fan system with a low speed relay in the TIPM, the high speed relay above the driver headlight, the voltage divider, and the DC brush fan just really wasn't optimal. Jeep decided to upgrade the system with the Pentastar, and they did. They went to an outrunner, which basically means the outer can turns on the motor. It's more of a pancake motor, and there's a reason for that. It gives it more torque so it can run a bigger fan. It runs a 19-inch fan blade. The 19-inch fan blade gives you a couple advantages. One, it allows the fan blade to run at a lower RPM and still pull more air. Two, it gives a bigger opening so that when you're going down the freeway or even just down the highway like I am right now, the natural airflow can pass through the radiator core more easily. If you have a dual fan setup especially, you have these two little 12-inch fans and the rest of the back of the radiator is blocked off by the shroud. The natural airflow can't go through. So if you got a 21-inch core with a 19-inch fan blade, you're letting almost all that air through. Then when the fan fires up, it's pretty much pulling air through the entire core. It's really a good setup. The Camaro SS fan is one step better, and we're going to talk about that right now. Kind of dispel some myths and rumors about how these fans work. The TIPM is actually what controls the fan. It powers the low speed on the 3.8 JK. It grounds the trigger on the high-speed relay. Yes, the engine computer senses the coolant temp, sends that over to the TIPM, and the TIPM controls the fan. So this does add one layer of complexity trying to control your fan properly. Well, when they came out with the Pentastar in 2012, they modernized and went to a much higher tech fan, and it shows because you can pick up a JK 3.8 fan for under $100, and the Pentastar fan is usually well over $200. So the price went up dramatically, and it should, because it's a much different fan. Now, the new fan is a PWM, or a pulse width modulated fan. So it uses basically a pulse train to control the speed of the fan. It's a digital signal. This time, the fan wires go directly to the battery. They're not powered off the TIPM. And you have to do that, because these fans can draw 20, 30 amps continuously. And if you're trying to run that kind of power through a sensitive electrical circuit, it's going to be trouble over time. So they run basically the power and ground to the fan module. Now they call this a fan module because the electronics for running the fan are inside the fan assembly. The earlier generation of this type of fan used a fan controller, and it was external. So essentially the fan controller was a separate module that had two big wires going over to the fan motor, and the fan motor was usually DC brushed. So again, you increase or decrease the voltage for the fan speed, but then it had a pulse width modulation signal between the fan controller and the ECM. That fan controller would then translate that signal into a voltage signal and put it out to the fan. Not ideal, but it was definitely a step up, the variable speed fan over the discrete on and off fan. Now GM has been using the 3 relay setup in the discrete fans for years, dual fans, and it works great. But these fans really are old technology, and you don't have really good control. They're either on or off. There's nothing in between. So essentially the fan will go on and off, kind of like an O2 sensor to make you be where you want to be as far as coolant temp goes. The nice thing about a variable speed fan is you can run it at a constant lower speed, hold a more consistent temperature. The fan's not going to be, and I don't know if you can hear in this Jeep I'm driving right now, but it's controlling the temperature for a lot of stuff, mainly for AC pressure right now. You can see we're still pushing over 300 psi. Let me turn this AC off and watch how that pressure just drops right off, and the fan control goes way down. You can't even hear the fan right now. So essentially with the Pentastar fan, they went to a modern fan. They went to an outrunner, so the outer can turns and it allows them more torque, so you can run a 19-inch fan blade, which is great on the engine core. It gives you a lot more natural airflow. It's just a better deal all the way around. In my opinion, they really screwed up with the, well, two things. One, using the TIPM to control the fan just adds a lot of complexity. The GM way of doing it, where the ECM gets all the signals in, it gets the coolant temp, and it gets the air intake temp and all that, and then it controls the fan directly. That works great. Why Chrysler decided to farm it out to the TIPM is just a decision they made, and I guess it works in the OEM vehicles, but I also think a lot of you guys know that it doesn't work a lot of the time. They had a lot of problems with the Pentastar fan. It would come on really high in the early JKs, like the 12s and 13s, when the engine was cool, and then when the engine was hot, it would slow down and just do weird things. So it's not optimal in my opinion, but it is what it is. Now, I'm getting hot. You can see that went way down. I'm going to turn the air conditioning back on, and you can watch that fan pressure, or that AC pressure, come up while I'm yakking. So the Pentastar fan used a, well, let me back up. There's basically a frequency that these fans run at. If you go to EFI Live or HP Tuners or whatever, they show you an EV PWM fan. They show you a electric PWM fan. They show you these different fan types. But what they're really doing is they're setting the frequency for you. The EV electric fan or PWM fan that you see in EFI Live and the other software was the old electro-viscous clutch fans that, and we're going to have to get into this a little bit more depth, and I guess I will, because at some point we're going to have to discuss this. It's the next day and it's hotter than it was yesterday, and here we are just stuck in this traffic. In any event, we got our air conditioning on, so we're staying cool, engine staying cool. We left off yesterday with the pulse width values. I don't pretend to know them all, but essentially the pulse width is the frequency or the hertz of the control of your fan. And why manufacturers just don't settle on one and use it all the time, I don't know, but I think they're actually moving in that direction. Most of the modern fans now run 100 hertz. The new Camaro SS fan is 100 hertz. Finally, the new JL and JT went to 100 hertz, so they're interchangeable with the SS fan. But the Pentastar fan was 10 hertz, and it was not only 10 hertz, but it was a negative coefficient 10 hertz, and I'll explain that in a minute. So if you go into like EFI Live and you go to the fan control, you're going to see discrete. Discrete just means on and off. It's going to put a ground signal out that's going to ground a relay that's going to trigger the fan on and off. Discrete fans were the mainstay for a lot of years. Well, really the mechanical fan was the mainstay for the majority of the life of the automobiles. But then in the 80s and 90s we started seeing more and more, and the Europeans of course adopted it before we did. But we started seeing more and more electric fans, and you say, what's the advantage of an electric fan? Well, the disadvantage, I would say, would be that it just simply can't pull as much air, or CFM, that's cubic feet per minute, as the mechanical fans. That's starting to not be true. Some of these new electric fans, especially the brushless outrunners, are pulling a lot of air. But in the old days, with the brushed in-runner fans, they just couldn't pull the 3,000-4,000 CFM that a proper mechanical fan could pull. And even amongst the mechanical fans, there was a lot of varieties. You had the clutch fan, the thermal clutch fan, which basically had this viscous coupling, they called it. It had like silicone fluid that, as the temperature got hotter and colder, would increase and decrease how much the fan would drive. And that was important because as far as economy goes, if you've got a fan putting out 4,000 CFM all the time, so if you took a fan that was basically fixed like an airplane propeller and you put it on your water pump, it's going to blow air. The faster the motor goes, the more air it's going to blow. So you're cruising down the highway at 2,500, 3,000 RPM, that fan's really going to be spinning up and pulling some air. Well, guess what? On the highway, you don't really need that much airflow because you have the natural airflow from the airstream coming into the grill. So you're kind of wasting energy. Now at low speed, when you're crawling in traffic, you need more airflow, but the engine is idling, it's going slow. So that fan can't pull enough air to keep the engine cool, especially with air conditioning. And that's one big advantage of the electric fan, is you can control the output regardless of the vehicle speed or RPM. In fact, I think on the diesel JKs, Jeep did end up putting an electric fan for low speed operation, especially with the air conditioning. So manufacturers used all sorts of methods to try to make the mechanical fan more efficient. Probably the most popular was the viscous clutch fan. It used a silicone fluid inside of this housing, and as the engine got hot, the fluid would get thinner, then that would somehow cause it to engage more and the fan would pull more. In fact, on some of those, when you fired them up when they were cold, you could literally grab the fan blade. The water pump would turn, but the fan blade wouldn't. But then, once it reached that temperature and that fan locked up, it really started to pull some air. And like I said, some of those setups could pull 4,000 CFM, and that's a lot of airflow. You probably heard the old Buicks and Cadillacs and Fords and from the 70s, when that fan kicked in, it was like a hurricane. There were some ill-fated attempts to even control it better. Lexus and some of the Europeans used hydraulic control of a fan, but it was really complex and, in my opinion, just over-engineered. Then we had the EV, or the electroviscous, that you see the PWM on your software. Essentially, they took a thermal clutch fan and they tried to control it electronically, and they put them in the Trailblazers and some of the other vehicles like back in the 90s, and in my opinion it was a failure. I don't think it really gave them what they wanted. So essentially the electric fan took over. Many vehicles have electric fans now, including our Jeeps. What's good about the electric fan? Well, you can control it whenever you want. You can get from 0 to 100% output. The DC brushed motors use voltage to control their speed. where electronically speed controlled fans, or ESC fans, use some kind of a signal, usually pulse width modulation. It's very similar to like a brushless motor in an RC car or aeroplane. Much more controllable. Instead of being on and off, you can go 1%, 10%, 20%, and get it exactly where you want it to be. Therefore, you don't have these inductive kicks going from off to high. So when we talked about the relays earlier, relays are used for a lot of things, but one of their basic functions is to control a high amperage circuit off of a low amperage trigger. So the TIPM can ground the trigger on a relay with very less than 1 amp, much less than 1 amp current, and control a 40-50 amp fan. So that was used for a lot of years. GM, Ford, Chrysler, they all used the relay controlled fans, and that was the mainstay for years and years. Now, Ford especially, I remember, started to go some variable speed fans in the Lincolns, and this is back in the 90s, and they actually worked pretty good. They went to some dual wound fans that had a low and a high that was done properly. There was a lot of different things tried, but what is the whole world coming down to now? And that's going to be an electronically speed controlled brushless outrunner fan, which is what the Camaro SS and the Pentastar are. Now, don't be fooled by the Pentastar fan. It's not as simple as you think. The Pentastar fan runs a 10 hertz signal, and not only is it 10 hertz, but it's negative. So essentially, the lower the pulse width, the faster the fan goes. And Chrysler kind of got themselves into a bind with that because it was just so different than everything else that it didn't integrate well, and they had their own issues integrating it into the Jeep. Chrysler did, when they came out with the JL, just go back to a standard positive coefficient pulse width 100 hertz fan, which I think made a lot of sense, and we've actually run them in our swaps and they work pretty good. I like the Camaro SS fan better. The Camaro SS fan is sealed where the JL fan is not. I haven't had a really hard look at the new JT heavy duty fans, but the SS fan does a really good job. It's really compact. It runs a 19-inch blade. It's very quiet when it's not needed. It's just a good fan, and because these things are sealed, ball bearing, brushless, they don't wear out like the old DC brushed fans. In fact, some of you probably know under hard use, you have to replace your JK fan, your 3.8 fan, every couple of years. Here in Vegas, we have to do that. But with the SS fan, not so much. So controlling the fan becomes critical now. We've moved away from the clutch fan. We've moved into the electric fan. How are we going to control it? Are we going to control it with a separate fan module, or are we going to control it with a self-contained module? And that's why the SS fan and the JL fan are called fan modules, because they have the module built into them. And it's a 3-wire hookup. Power, ground, which go right to the battery, so you can pull as many amps as you need right from the battery. And then the signal wire, which is just a really low current wire that goes to the control module. Now, it can go to the TIPM, like it does in the JK, or it can go to the ECM, like it does in the GM. Now, in my opinion, going to the ECM makes a lot more sense than the TIPM. The TIPM's a gateway module. It does a lot of stuff, but the engine control module is really responsible for engine performance. So transmission temperature, air intake temperature, engine coolant temperature, even air conditioning pressure is better controlled by the ECM, in my opinion, because the ECM is also controlling the air compressor. So running it through the TIPM is kind of a goofy thing, in my opinion. I think the GM has it set up better. So it's just a 3-wire hookup. Works really good. It's been around now for quite a while, and it's a setup that we have settled on. We don't like supporting the Pentastar fan, even though we have, because of the goofy programming. We don't like supporting the the single wound JK fan from a 3.8 that has the voltage divider and gives you 2 speeds. They're 17-inch blades. They don't put out near the CFM. Here I am in Vegas right now, pushing 120 degrees with the air conditioning on, and we all know that under extreme conditions the JKs overheat, even with the V6. So you might as well get as much fan as you can get, and the SS fan has pretty much become standard in our swaps. Now, we can talk about the fan all day, but there's a lot of other considerations when it comes to cooling. Remember, you got transmission fluid to cool. You have engine oil to cool. You have Freon in your air conditioning system to cool. And one of the things about the JK is it just puts all this stuff into the engine compartment. And putting all this heat into the engine compartment means that you are pulling low pressure air into a high pressure zone, which can be difficult. And then guys are putting these fender wells on that aren't vented, so they're trapping that air in. They're putting headers on that aren't wrapped. And I could go on. I mean, just use common sense. They've got a reduced opening grill. Then they've got a bumper, hoops, and everything else in front of that. It's like the fan is trying to suck through a straw in 120 degree temperature with the air conditioning on, and it's just not going to happen. It's not good. So 1, leave your grill unobstructed. Leave all 7 of those openings, and I do believe Jeep has a copyright or a trademark on that grill. Leave them all open. Don't put any screen mesh in there. Yeah, you get some bugs, you clean them out, whatever. And speaking of that, check your AC condenser often. Chrysler uses a high density AC condenser core, so it's got fins really close together, and they trap dirt and dust and particles and bugs, and that can block a lot of the airflow going through to your radiator. So check that carefully. My recommendation is go with an aftermarket condenser. I find that some of the aftermarket condensers, 1, use a softer aluminum, so they don't tend to crack like the OE radiators, and the fin count is less, so it gives you more space for air to go through and not plug up. Now these JKs are off-road vehicles, and you get off-road, especially in a wagon train, you're going to be sucking a lot of dirt in. I'm not arguing that the high efficiency core probably has an advantage under optimal circumstances, but in the circumstances that we run our JKs, I think you're going to be better off with the aftermarket AC condenser, and you want to go to a manual condenser, because the transmission cooler in the bottom of the AC condenser on these JKs is next to useless. Chrysler found that out in the old days when JK started to burn because the transmission fluid started to spit onto the exhaust manifolds and light them on fire, and they did that upgrade where it flashed hot oil on the dash, and Mopar came out with a tranny cooler, and really that's what you need to do. When Chrysler came out with the Pentastar, they added a really big cooler up front, which is a great cooler, and I recommend you run it if you can. So going to the manual condenser is going to get more airflow down there into the radiator. Putting or fitting a proper transmission cooler up front is critical. Now, do not fall into the trap of putting all sorts of coolers up there with engine oil coolers, power steering coolers, tranny coolers, and just stuffing them all behind the grill, because then you're just going to choke off the radiator and you're going to overheat. You're just trying to dump all this heat into the engine compartment. What you want to do is off-board as much of that heat as you can. Essentially, the GM computer controlling the fan for transmission temperature, air intake temperature, AC pressure, engine coolant, vehicle speed, all that, you basically have the engine coolant driving the fan up to about 75%. Now let me say this, most fans can only be driven up to about 90%. Then they shut off. They go into a diagnostic mode or a safe mode or a shutdown mode or cool down mode, whatever. So if you overdrive these things, and you guys that don't have your AC pressure sensors hooked up, and the computer thinks the AC pressure is at 400 or 500 pounds, you hear that fan wind up, it starts screaming, then it shuts off. It's gone beyond its limit. So we're only putting about 75% out for engine coolant temp, and the reason is we have riders. I call them riders. You have things like air intake temp. If that hits 200 degrees, the fan's going to wind up. Transmission temp. If that hits 200 degrees, the fan's going to wind up. AC pressure, obviously. When that thing hits 300 pounds or 300 psi, it's really going to wind up. And the problem is you can overdrive the fan. So these riders can be limited, meaning you're only going to get so much out of this thing. And a lot of guys will block their grill off and call me up and say, hey, my engine's running cool even on the highway, but they're running at 90%. They're running on the ragged edge, and that fan is working its brains out to try to keep that operating system cool. Now, on a day like today, and my dash is showing 124, I'm going to say we're pushing 120 degrees right now. You're going to see that fan wind up to 70, 80, 90%. You're not going to get around that. But if it was 65 degrees outside and I'm pushing 80% on the fan, I got a problem. I got an airflow problem. Another thing you guys want to monitor is your spark knob. When it gets really hot out and the fuel is volatile, you can have a problem. There's a lot more to talk about on cooling, so I'm going to cut the video off here, and we're going to take this Jeep up to those mountains and let's see how it goes. The drone overheated again. We're going to let it cool off. You don't hear the Camaro fan wind up this much very often, but when it does, it lets you know it's there. Check it out. This is going through the radiator, condenser, and transmission cooler.